when we talk about perception, the difference between sensation is gathering data, perception is putting that data together. Now, we put that data together according to certain rules. And the biggest question is, well, not the biggest, but a question is, where do we get them? And if we do have rules with which we assemble the world, I mean, take all these little bits of data and we make our own reality. We make our own reality according to rules. Can you break the rules? What I would like you to do right now is look around this classroom, and I would like you to not see it as you normally see it. Can you? Now, you could blur your vision, but see, that's kind of blurring, that's changing your sensation. I don't think you can change how your eyes physiologically work. Can you change what your mind does with the data? I'll say it again for the slower children in the back. All right. Can you change what your mind does with the incoming sensory data? If you hear your favorite song, can you not like it? All right. If you like chocolate, can you not like it? I mean, you can't change the chemical reaction on your tongue. You can't change the aroma of chocolate as it hits your olfactory bulb. But we're putting these things together. When you look at something moving across your visual field, can you change how you perceive it? And now that's the question. And I'm not sure, because I think these rules are really good, but they're not perfect. How do we know we're not perfect? Because of one word: illusions. So when we talk about perception, one more time, the idea is we take data that's gathered, raw bits of data, and we put it together. And I don't think we know how we put it together. It's done automatically for us. Is it our subconscious, our unconscious? Well, we're going to get into that in a different unit. Different levels of the mind do things for us automatically. And I think if you read the word perception, you're going to realize that, guess what? That's not the right word. That's not perception. I spelled it wrong. Because there's no I in there. Of course, that's a 1. But notice how we automatically perceive things in the way that makes the most sense. Why would a teacher who started a class, and I probably said the word perception 10 times before you read that word, so you're going to assume. Now, the raw data hitting your eyes is going to be white light with some black letters, and then you're going to assume the word perception. Your mind assembled it incorrectly. But incorrectly though it may be, it was efficient, it was smart. And that's what we're looking at, is how often does our mind incorrectly assemble bits of data? A lot of times when we talk about perception, everyone always wants to know about ESP, extrasensory perception. Well, let's figure it out. We got vision, we got hearing, we got touch, we got taste, we got smell, we got a vestibular system to control balance. So really we have 6 senses. Do we have a 7th or an 8th? And I don't know that we do. I can't prove it. And what I mean is I can't prove it. I've never done the research. There have been some pretty prominent psychologists that have done their best to see if they can find evidence. Not just any evidence, but here's the word: significant evidence, where P is smaller than 0.05, that people can know things without using their 5 senses. Now, I think everyone would like that to happen because we've all seen countless science fiction movies. We've all seen countless comic books. We've all seen a whole bunch of stuff where people just know stuff. They get stuff. Either they can tell the future, they can read minds, they can see through a wall called remote viewing. They can see far away. All right, I'm not sure about all that. But if you're willing to believe that perception is gathering data, I think a lot of us don't see all of the data. I don't think we look at, next time you're talking to someone, I would like you to look at the muscles underneath their eyes. Most of the time we talk to someone, we're darn sure not looking at them. You know what we're doing? We're waiting for them to stop talking so we can talk. That's the American way, isn't it? Why would we even listen? Because my idea is clearly better than someone else. I was in a political discussion with someone, and he was giving me all these facts, and those facts were messing up my opinion. And so what I said, stop giving me facts, because I got to tell you my opinion. Isn't that how most of us talk? What I'm suggesting is there is so much data out there about the set of someone's shoulders, about their facial expression. And I'm willing to bet, I don't know if I can do it today, but I'm going to try to read one of your minds. You think this is possible? Now, am I going to really read your mind? Do I really have Jedi powers? Maybe. All right, but in my own mind, you should see. Trust me, my world is a lot more fun than your world. All right, just saying, because I don't believe in these things called rules or moral boundaries. Just saying. All right, so here's what we're looking at. I need a volunteer, and here's my idea. I'm going to try to read your mind by picking up on a whole bunch of data, mainly looking at your face, body position, and tone of voice. So I need a volunteer. I'm going to ask you certain numbers, and I'm going to try to pick by asking certain questions, or maybe reading you. Maybe this is a personality test. All right, what number you have. I need a volunteer. All right, we got one. Okay. Now, to be honest, I don't know too much about you, so this will be a pretty good test. You're pretty quiet in the back of the class. You've contributed a little bit. All right, you got a little sass because you gave it to me. All right, that's fine. So what I'm going to do is I believe in prime numbers. I believe in the power of 3. All right, I want you to think of a 3-digit number, but please don't be like 111 or 666 because I know how you all are, devil worshippers. All right, then. So it can't repeat. So think of a 3-digit number and write it down, like 123 or 321. All right, something like that. All right, and what I want to do, you got it? All right, you can see it? All right, you got a little smirk, but now she's uncomfortable. Okay, now I want you to reverse the number. So if you wrote 123, then I want you to write 321. Okay, now watch what you're going to do. So if you wrote 123 or 321, so you've got 2 3-digit numbers. Don't look down, stare at me now. Okay. All right, that's cool. Did you see this right here? Why are you so nervous? Okay, that's fine. That's a pretty good answer. So here's what I want you to do now. Take the smaller number and subtract it from the bigger. So if you have 321, then underneath it put 123 and subtract the smaller from the bigger.
Okay, I got it.
You have a 3-digit number. Is it the same one as on your paper?
No.
Okay. I would think so. I'm hesitant to even ask.
Okay, go ahead.
All right. Do you have a 7? Okay, 3. I think I got it. All right. I definitely think you're odd.
Why?
Because how angry do you get most of the time? Yeah? I know. It's quite obvious just from the set of your shoulders. All right, one more time. I think this is a tough one because I thought you were going to be easier. I got to go with odd. Do you have a 5? Yeah. See, this is going to be a little bit scary. I think I got it. If we were to look at your numbers, if A is 1 and B is 2, okay, so as far as I know, you do have a 5 in there. So 5 is going to be, okay, 5 is going to be an E. Okay? There's your number, 495. Yeah. You are pretty dark and evil, aren't you? 495 was your number. All right. Who else wants me to read them? All right, then. Everyone's like, whoa. All right, then. All right, at the end of class, if we have time. At the end of class, we got to go on with this. Oh, I know, I got you a little bit interested in this. So what are we looking at? The concept was either I could read her mind, okay, which maybe you never know because I am from the future. And how would you disprove that? All right. Or I hypnotized you and told you to forget. How would you disprove that? Okay. Or what we're doing is we're gathering subtle clues from set of the shoulders. Which muscle flexed? Okay. Or maybe, just maybe, I gave her a confusing task. I didn't draw how to do it. I gave her a whole bunch of things that made her feel uncomfortable and then saw how she reacted under stress. Is that fair? All right, let's jump on to this thing called perception. Got it? Good. So here we go. One of the words we're going to have to know is called feature detectors. And what a feature detector means is it's kind of the ultimate in reductionism. We're taking this complex thing called perception, how we construct reality. And we're going to break it down to one neuron. And a feature detector is basically that. One neuron sees one thing, one very basic shape, one very basic construct. One neuron is going to be responsible for vertical lines. One neuron is going to be responsible for horizontal lines. Now, does this mean we have a feature detector for everything we can see? We look around this room. You have a feature detector for a yellow pen going horizontal, a yellow pen vertically, a yellow pen sharpened, a yellow pen unsharpened. No, I don't think so. I don't think we have a feature detector for all of the possible things we could do. Might we have a feature detector for yellow, for red? So please know that we don't have a feature detector for every possible thing we can see, because everything we see is usually complex and it's a blend of a bunch of feature detectors. Go ahead.
Are feature detectors only for visual fields, or is it also?
As far as I know, they've only been studied for visual fields because, to be honest, that's where we construct most of our reality. Could it be? I think it could be, but I don't know of research going into auditory feature detectors. All right, let's talk about this thing called a binding problem, or binding phenomenon. And think of it, we're linking features together so we see unified objects. And if you don't believe it, you're doing it right now. You're doing it right now. If you're reading, there's not one of you that is processing the dot above a lowercase I. There's not one of you that's processing, well, what font is that written in? You're not processing individual letters. Your brain, your mind, is taking all of the little bits of data that not only make up words, I'm talking about, think of all the things that make up letters. In order to make up a letter, you have to have a vertical line. You're going to have a loop, an arc, a circle. You're going to have a horizontal line. And all of those little bits of data combine to form, this is amazing, wait for it, a thought, meaning. That's truly unbelievably magical, but because it happens every day automatically, we don't pay any attention to it. We only pay attention to it when the system breaks down. And the system breaks down in normal people under illusions. When I say normal, I'm talking neurotypical. But we do like to study folks with brain damage. We do like to study folks with congenital defects, so they process the world differently. Got it? Let's jump onto the law of Prägnanz. It basically means we see the world in the most efficient way possible. Mother Nature doesn't do anything by accident, and Mother Nature is a big fan of efficiency. That's why we don't have a third leg. If you had a third leg, where would you put it? Would it slow you down or would it make you faster? Probably slow you down. All right, is anyone here imagining where would you put a third leg? But would you like it? Maybe coming out your butt so you'd always have a place to sit? It would be like a stool. That's kind of weird. Somebody's like, huh? I don't know what goes on in my mind, but that one actually scared myself right there. An illusory conjunction is just a fancy name for an illusion. An illusory conjunction is just a fancy name for an illusion. Now I was like, ooh, I like optical illusions. Well, if you like optical illusions, well, then you don't really like anything, because there's no such thing as an optical illusion. Your eye isn't fooled. Your eye is not fooled at all. Your eye is sending raw data to your brain. Every single optical illusion you see is actually called a neurological illusion. It's your brain that's fooled. Your eye's not fooled. It's your brain that's fooled. Your brain is putting things together the wrong way. Let's look at top-down processing. Top-down processing means we have the whole idea before we have the facts. I think when you read, you don't read word by word. And I don't even think you read letter by letter. You get the whole idea. And if we look at this chair, how do you know this is a chair? Anyone ever seen this chair before? You have. I don't think you have, because I stole this from another teacher. She's a weaker teacher and slow. All right? So I said, I'm going to take your chair. She said, oh, but I need that. I said, you can't stop me. So I took her chair. What's wrong with me? Why would I even say that? How do you know how do you know this is a chair? And here's the really weird answer according to top-down processing. You know this is a chair? Well, because you know it's a chair. It's like the worst, most circular logic in the world. It's like, how do you define a word if you use the word in the definition? But this is how most of us operate. We take all of the data. I don't think anyone here looked at this like, holy crap, I don't know what that is. I've never seen that exact chair before in that position. Let me analyze it. Let me see. It has 4 cylinders. It has a horizontal plane. It has a vertical plane. That could be a chair, but let me do some hypothesis testing. No one's done that. All right then, boys and girls, let's write down bottom-up processing. Bottom-up processing means we we perceive individual things, or we sense individual things, and then we build it, and we build the conclusion from the data. I think on some level we do this. I said, what'd I say? I said do. It's like, all right, let's look at this. When we're looking at bottom-up processing, I think this little diagram will give us a pretty good idea of what the heck we're talking about. Because when we look at this shape, if we look at a briefcase or a suitcase, the reality is all it is a rectangle or a prism and an arc for a handle. We don't consciously see this stuff. We perceive following rules that are automatic, instant, and in some cases irresistible. And I've challenged you before, I'll challenge you again. I would like you to see the world in a way that is not your normal way of seeing the world. I would like you to see the Promethean screen as a whole bunch of rectangles. I would like you to see your pen as nothing but a long cylinder and then a cone. I don't think you can. We see the whole, we don't see the parts, and that's top-down processing. Oh, look at all this fresh stuff we get to write down. We organize the perceptual world according to rules. We organize the perceptual world according to rules. What are the rules? We're going to call them Gestalt rules. And we've seen this word before. We're going to call it Gestalt rules. We've seen this word before. And Gestalt means the whole is more than the sum of its parts. And this is important because as you look around, as you perceive music, you don't say, this note goes with this note goes with this. Oh, that's a pleasant sound. You don't consciously do it. You look at the whole, you perceive the whole, not the random bits of unconnected data. That's sensation. Perception is the whole is more than the sum of its parts. A couple things with these. They work 99% of the time. We like to study the time where perceptions don't work. Psychologists are fascinated with illusions. Not necessarily illusions, but how people make mistakes. Because we find out the mistakes of the perceptual system, then we start to get insight into how people actually do assemble color, assemble motion, assemble shapes into reality. Do we all do it the same way? And if we all do it the same way, why do we come up with different opinions? Or do we perceive the world differently? Now, if we perceive the world differently, does that mean we're all following different perceptual rules? And if we're following different perceptual rules, maybe we learned them. But does a baby have to learn how to view the world, or is a baby born with these rules? We got a lot of good questions that if we kind of chase down these questions to their end, we might give us an idea of, well, maybe, just maybe, why is someone crazy? Why are there disagreements? Is it because they're thinking the wrong thing? Sure. But what are thoughts made of? Thoughts are made of perceptions. What are perceptions made of? Perceptions are made of sensations. If we could track down this system, maybe we can find the error. I like to use the metaphor of an operating system. And when I say an operating system, what I'm basically suggesting is computers are created without a lot of software. Computers are created without a lot of software. But they have some basic rules they must follow. Is that the way humans are? Does a baby have to learn to perceive the world? I don't know what they sell in a store called Babies R Us. All right? I don't know that you could buy and sell babies. But if you could buy and sell babies, I want you to get one. All right? And I want you to raise that baby in a very interesting environment. I want you to raise a baby in a perfectly spherical room where there are no straight lines or right angles of any kind. No, the baby will play with nothing but round and oblong shapes. The baby's crib will basically be a giant bowl. All right? The baby's blanket will be nothing but a three-dimensional blobbish shape. Now, I know it's kind of weird. Who thinks of these things? Well, again, where do you see my bottomless pockets? How many things do you think you could ever fit in there? That would be amazing. But I disagree. Let's go on with the idea of raising a baby for the first 5 years in its life where it could never see a right angle. Will the baby every day of its life think, something's wrong? Or will the baby say, this is how the world is because of plasticity, and then you take the baby out of its really weird environment and you put it into a place like this where you got nothing but rectangles? What's going to happen to the baby's brain? What's going to happen to the baby's mind? Do we learn these rules or are we conceived with them? We're not born with language, but we're born with the ability to learn language. Are we born with certain rules? I don't know. All right. The last thing we're going to say about these rules, it is unconscious and automatic. And I've said it before. I would like you to perceive the world in a way that you're not perceiving right now. Break the rules. break the rules with which you've been seeing the world for your whole life? And I don't know if you can. It's an interesting concept. So now these rules work, but do they limit us? Are they limiting our creativity and how we can think? I think it's chart time. How many of y'all love charts? So if we organize the Gestalt rules into a chart, this is what we're going to get. Now this is not all of them, but it helps us, again, organize the world. Charts are lonely people's good friends, and we group things together. I think when we look at Gestalt rules, we're finding almost a natural inclination for humans to group things together. We like to put like with like. You don't believe me? Next time you clean your room. Dirty clothes go with dirty clothes, clean clothes go with clean clothes. When you're going to clean out your notebook or your locker, stuff to keep, stuff to throw away. And when you're throwing away trash, things to be recycled. When you're looking through the yearbook, ugly people? Never mind, that's not right. Why would we say that? When we talk, one of the first Gestalt rules, and we're not going to hit all of them, there's a bunch of Gestalt rules, but primary ones we're going to hit proximity. Ready? This simply means this. We group things together that are near each other. When we look at the Gestalt rule of proximity, we're going to group things together. And I want you to tell me how many groups do you see? Okay, so we'll make a couple groups of dots. So if we're going to look at the perceptual cue of proximity, and we want to group things together, how many groups do you see? We got dot, 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 we got dot. How many groups do you see? 3. How come you don't see 2 groups? How come you don't see 1 group, 2 group? Can you see it this way? Notice you automatically processed. You didn't have much of a choice. If we were going to do this again, and we were to clear that, and now we're going to make a whole bunch of dots, and I were to say this, all right? How many groups do you see? Anyone see 2? How do you racist automatically group color with color? You kind of do. And like, I can't help it. I grew up in Alabama. All right, then. I have 2 names like Billy Bob and Lukey Joe. All right, then. That's not right. Why would I say that? What we're looking at when we look at these perceptual cues is we automatically group things that are close to each other. We group things that look like each other as being together. Continuity. Look, you guys have seen my writing. All right? You make fun of my horrible spasm. It looks like I'm actually getting beaten up when I'm writing. It looks like I'm having a seizure. I don't think ever in the history of me writing on this board have I ever closed an O. Ever. Yet you perceive my almost U's as O's. Notice that your mind automatically will close in my unclosed O. Why is that? You know, it's like, that's an H, that's an E, that's LL. What is that shape? I don't know. It's threatening. It's scary. No, you don't do that. You automatically say, oh, that's an O. Why do you do that? Because of the what's called perceptual cue of closure. Closure and continuity. Continuity is going to be kind of linear, meaning that you're going to see that as an arrow. You're going to see that as an arrow. You can't not see it. Phi phenomenon. It basically means it's another perceptual cue, and it's kind of cool. If you've ever gone by some kind of beach town, and they have motels that say vacancy, and they have a whole bunch of flashing lights that look like an arrow. They're not flashing lights, and the arrow isn't, the lights aren't moving. What's happening is you have light bulb, light bulb, light bulb, light bulb. And when this one goes on, that one goes off. When this one goes on, and it gives us the illusion that the light is actually traveling. This is the process by which we see pretty much everything on any glowing square. How much of your day is spent staring at a glowing square? How many hours per day do you stare at your phone, your computer, and your TV? A lot. And I think we have the Phi phenomenon. The reality is the person across your screen, it's different lights at a certain frequency. You do it just right and it looks like the lights are flowing. We call that the Phi phenomenon. Questions on that? Classic Gestalt rule. Classic Gestalt rule is what we call figure ground. And this is the most classic one. You see faces or a vase, but you can't see both at the same time. You can't see both at the same time. Just like you cannot read and listen to music at the same time. You can switch back and forth very quickly. You cannot drive and text at the same time. I can. I'm really good. No, you can't. Your attention's either on one or your attention's on the other. Can anyone here? Does anyone here think they got it? You think you can see both at the same time? You out of 7, you're the one out of 7 billion people. If you imagine, what are you focusing on? The figure or the background? You're saying both. How many of y'all are suspicious? I'm suspicious. Look, you have no friends. The whole class raise their hand. All right, this is an interesting question because, hold on, you get a teacher like, you can't do it. And then your response is, prove I can't. Prove I can't. All right, and next time your teacher says, no, you can't turn that in late, prove I can't. Don't do that. All right, something to think about that. Cops like, you can't drive fast. Prove I can. Let me rephrase. You might be able to see, but we have to define seeing. You can't focus or concentrate on more than one thing. You can't focus or concentrate on more than one thing. Let's do, let me kind of prove that by watching a classic video.
This is an awareness test. How many passes does the team in white make? The answer is 13. But did you see the moonwalking bear?
Notice the misdirection. Everyone is focused on counting the number of passes the team with the white shirts made. Did you sense the moonwalking bear? Yes. Did you sense it? We need to distinguish between did you sense the moonwalking bear? And the answer is yeah, you clearly did. Light was coming and hitting your eyes, but you didn't perceive it. Now, let me ask you a question. When they replayed it, and you watch the moonwalking bear, it's like, whoa, that's so cool, no way. How many passes did they make? You didn't pay attention.
13.
Are you sure?
Yeah.
Are you sure? You mean no one has ever messed with video in your life? I'm just suggesting that once you were so focused on the moonwalking bear, what else didn't you see? The number of passes. So what we're suggesting is watching selective perception tasks are a great concept of sensation. Your body is sending the afferent signal to your brain. Your brain's like, nope, not now. I can only concentrate on one thing at a time. It's going to be kind of a theme throughout this class. You can only concentrate on one thing at a time.